the numbers in mind. Try to simplify your x and y. Don't forget the rest. Go back and study your test. Like English, Sir Angry, what it's a piece of pie to find x.
Hey math lovers, let's go over 1.64, the discriminant real roots. Go ahead and let's complete this, do this with me. Well, what's the quadratic formula? X equals negative b plus or minus square root b squared minus 4ac all over 2a. Okay, then it says circle the radicand, which is the stuff inside or underneath the radical. So let's go ahead and circle this. Notice the 2a in the denominator is not. This part that I just circled is called the discriminant. Okay, so we have this sentence frame here that can help us. The discriminant is blank and there is our or blank roots. Now before we do that, let's go over to this chart over here. Consider ax squared plus bx plus c. That's standard form. Let's write that. That's a review. Where a, b, and c are rational numbers and a is not equal to 0. So if I drew a graph that looked like this, and it crosses the x-axis how many times? 2 times. We would call these two reals. Two reals. Sometimes they are rational roots, meaning they have an ending. And this happens when the discriminant b squared minus 4ac is greater than 0 and b squared minus 4ac is a perfect square. Okay, you'll get irrational roots when you have the same scenario. B squared minus 4ac is greater than 0 and b squared minus 4ac is not a perfect square. Okay, so I'm just going to point this out. So right now we have them to be greater than 0. If I take this and if it's equal to 0, we will get one real rational. Okay, what does this one look like? This is the situation where I call it a double root. It's a parabola that touches the x-axis once, but it counts as a double root. So that's when the discriminant is equal to 0. And the last situation we've talked about is what happens if it does not touch the x-axis. Actually, let's do something different. What happens if it doesn't touch? This is when it is less than 0. B squared minus 4ac is less than 0. You're going to get two complex roots. Okay? Alright. Let's try an example, and this should make more sense. This example, given 2x squared minus 10x plus 7 equal to 0, let's go ahead and find the discriminant. Find discriminant. Okay, this one we just need our formula. B squared minus 4ac. And then we're going to put an inequality in this yellow box. Okay, so A is 2, B is negative 10, C is 7. So B is negative 10, A is 2, and C is 7. Let's go ahead and just simplify the left side and see what happens. That's 100. Negative 4 times 2 is negative 8, and negative 8 times 7 is negative 56. And this would give us 44. So what inequality would you put here? Well, 44 is what? Greater than 0. Okay? So how does this sentence frame work? The discriminant is 44. And let's look for that inequality there. And right here, we don't have a perfect square. So we can say that there are two it's not a perfect square, so we can say two real irrational roots. Two real rational roots. Okay? So that's how you would use the chart. Okay, directions. For questions 24 to 29, complete 3 problems, so skip 3 problems. Find the value of the discriminant for each quadratic equation, then describe the number and type of roots for each equation. Box your answers. Note, questions 20 to 23 were skipped on purpose. Okay. So, I have it set equal to 0. I can just identify my A, B, and C. I write down the formula for the discriminant. And I'm just going to do a substitution. The B value is negative 8. A value is 1. C is 16. And you get 64 minus 64. So I have 0. Therefore, the inequality I'm putting here is that it's equal to 0. And if it's equal to 0, look at our chart. You have 1, the discriminant is 0, and we have 1 real rational root. 1 real rational root. So the discriminant is equal to 0, and we have 1 real rational root. Number 25, it's already set equal to 0. A is 1, B is negative 11, C is negative 26. Write down my formula for the discriminant, b squared minus 4ac. And we're going to compare that to 0. The b value is negative 11, a value is 1, and c value is negative 26. So negative 11 squared is 121. Negative 4 times a negative 26 is some kind of big positive number. 4 extra 2, 8, 104. So I'm going to get 225. And what inequality am I going to put there? It is greater. So if I look at my chart, which one is greater? This one is not a perfect square. Actually, 225. Was it 225? Yeah, 225, okay, pay attention, is a perfect square. So we would use that top option. Two real rational roots. What did I just do? So the discriminant is 225. That number is a perfect square, therefore we have 2 real rational roots. Number 26. 3x squared minus 2x plus 0. Okay, why did I do that? It's because you don't have a c value. And then here you can just identify A is 3, B is -2, and C is 0. Discriminant formula. We're going to substitute. Minus 12. 12 times 0 is 0. So 4 and 0. So that would be a greater than. And again, is 4 a perfect square? It is. So the discriminant is 4. And it is, so we just need this one. 2 real rational roots. Number 27, A, B, C. Write down a formula. Let's go ahead and do a substitution. B is 7, A is 20, and C is -3. If you're getting stuck here, you're essentially doing the order of operations to simplify. So 49, and then multiplication left to right, -80. Positive 240. So 289. And if you're not sure it's a perfect square, just go to your calculator. Square root, which is over there on the left side in yellow, so second x squared, 289. And this is how you know it's a perfect square. It's a perfect square when there's no decimals there, because think about it, 17 times 17 gives me 289. It makes a box that's 17 by 17. Does that make sense? So we can say that it is greater. It is a perfect square. So I'm going to go ahead and just copy this one, 2 real rational roots. Again, the reason why is square root of 289 is 17. So this is my answer. 289 is a discriminant, and we have 2 real rational roots. Number 28 looks a little tricky, so let's go ahead and rewrite it. Okay, 5x squared minus 6 equals 0. Why did I put that space here? Look at this. Zoom in so you get this. Ax squared. Okay, there is no something with an x, so this would be the bx plus c. That means the bx is 0x. Do you see why I always write down the formula? So now I know that a is 5, b is 0, c is -6. Write down the discriminant formula always. B value is 0. A is 5, C is -6. 0, -20. -20 times a -6 is positive 120. And so I get 120 is what? Greater than. If that is greater than, and it's not a perfect square, that would be 2 irrational roots. Which means when you use the quadratic formula, your answers will be like 1.7 or something like that. 7.3, and decimals keep repeating. Paste. There it is. So discriminant is 120, and you have 2 real irrational roots. It'll cross the x-axis, and the numbers will be like decimals. 29. x squared minus 6 equals 0. Again, write the formula underneath for standard form. And you realize that none of those have a x on it. So this would be a 0x. This is super important because we're later going to learn that we're going to need those that are kind of missing gaps. B is 6, C is negative 6. B value is 0. Zero, negative 4 times 1 is negative 4. Negative 4 times negative 6 is plus 24. So this will give us 24 to 0, and that would be greater than. Is it a perfect square? You can test it again. Second square 24, press right to get out of the red. And it's not. 4.89 times 4.89 will give you very close to 24. So it's not a perfect square because it is not a whole number. Okay, so you go back up to your chart. It's not. So I'm going to copy this one. And that was 1.64. Finding the discriminant where we have real roots.